Bismillah ar-Rahman ar-Rahim, my dear students of Ajman University, College of Pharmacy and Health Sciences, second year for the course Pharmaceutical Dosage Forms 1. This is a continuation for part 2, so this is part 3, and we will be talking about quality control of tablets, and specifically we will talk about the physical tests. If you remember, in our last lecture, we classified the quality control tests to 3 categories. The first is the chemical tests. We discussed that under chemical tests, there are 3 different tests that we can do. One in the chemical content or chemical potency test, and the other one is uniformity of chemical content. The third is purity test. You should be able to differentiate between these 3 and pay attention to the uniformity of content test, because we're gonna differentiate this one from weight variation test that we will talk about it under the physical tests. Physical tests will include 2 subcategories. The first one اللي هو official tests. Now, when we say official, means it's a standard tests that are included in the major pharmacopoeias. So usually it's required. And these include the weight variation test, disintegration test, dissolution test, resistance to crushing test, friability test. The other category is non-official. Non-official, still these tests can be done, but there is no such requirement in the pharmacopoeia, although standards do exist for such tests. Here we only will talk about uniformity of tablet diameter test. Also, in our last discussion, we talked about microbiological tests. Remember here that we do not intend, or it's not our intention to produce sterile tablets. Rather, we want to have hygienic tablets. Okay, and hygienic tablets means that there is a limit in the number of bacteria that are present in 1 gram of drug or of the formulation. There is also a limit for fungi, and most importantly, that there should not be any pathogenic bacteria at all. This is what we mean by hygienic tablets or product. Now, if we go to our main discussion today, which is the physical tests. The first of these tests that we will talk about is weight variation test. طبعا, this is in accordance with the British Pharmacopoeia 2003, and it is similar to that of 2018 as well. And if you remember, in my last presentation, I asked you to go and refer to these tests in the pharmacopoeia. And our library has both the United States Pharmacopoeia 2018 and the British Pharmacopoeia 2018 as well. Okay, now let's talk about weight variation. Here we are talking about the total weight of produced tablet, which means, I mean here, I'm talking about the active ingredients plus the excipients in the tablet. Okay? So what we are looking at here is we want to see if each tablet weighs similar to other tablets. Okay, يعني I'm not talking about exactly the same weight, but very close weight to other tablets. So we want to say, or we want to see the variation in weights. Is this variation acceptable? Is it small enough to allow the batch to pass the test or not? طيب, let's first talk about before we talk about the test itself, let's talk about what could be happening that will cause weight variation. Now, let me just draw something for you here, okay? Now, you remember when we talked about die cavity. In this die cavity, there is the lower punch and there is the upper punch that does the compression, and your formulation will be filled in this die cavity. So what could happen that the amount that comes here is different maybe in each tablet that is produced. So what might be happening? Who knows? Well, one of the reasons for variation in the amount that comes here, or the most important reason, is the flow of the powder. If powder or formulation flow is not excellent or very good, then there will not be consistent filling of this die cavity. What does it mean? It means that sometimes the die cavity will be completely filled, sometimes partially filled. When I say partially filled, means maybe 90%, 95%, 80%, 85%. So it will not be completely filled. And this will cause weight variation after the compression of the formulation. So the major cause for this one is poor flow. And what is the reason behind poor flow? Well, one reason could be variation in granular size. Now, variation in granular size can cause two things. One is poor flow. Why it can cause poor flow? Because smaller granules can come between larger granules, causing increase in contact areas between granules. So when there is increase in contact areas, there will be more friction, and this will cause poor flow. Another reason why granule variation in size can cause weight variation, who remember segregation? We said that small particles, or in this case granules, can pass between the large ones. So you will end up in a formulation. At the bottom of the formulation container, you have small granules, and at the top you have the larger granules. When you put, or when you start the machine to do the tableting, initially what we'll get here is the smaller granules, right? Because they are at the bottom of the hopper. Because you remember that the formulation will get from the hopper to hopper shoe and then to the die cavity. So if at the bottom you have smaller granules and smaller granules fill this die cavity, the weight of the tablets produced from smaller granules will be different from the weight produced from later on larger granules. So this is another reason why variation in granular size can cause this problem in filling. Another thing which can cause poor flow, damp granules. Damp means moistened or wet. It's not dried. Let me tell you something here. When we prepare granules, for example by wet granulation, which is the most commonly used method, طبعا we do that. Why? Because these granules will be readily compressible. They have better flow. Then when we do that by wet method, of course, after you wet your mixture, you need to granulate the mixture and then dry the granules, because the granules are wet. When you do drying, Now, if you don't reach the end point of drying, when I say the end point, it doesn't mean that there will be zero moisture content in the granules. No. But there is a certain percentage that should be left. Yani moisture in the granules should be there. But if I don't dry it to that end point, which may be 4% of moisture in the granules, if I don't reach that percentage, for example, I leave it to 10%, then the granules will be damp, and this will cause poor flow, because the presence of moisture will cause the granules to stick to each other, okay, and will make it difficult for the granules to flow. Another reason why there might be poor flow اللي هو الglidance. Maybe I did not add sufficient glidance to the formulation, or I did not mix the glidance well in the formulation. This will cause poor flow. Eventually it will cause variation في الtablet weight. Now I want you to remember this very clearly, is whatever cause variation in weight, whatever cause weight variation, will also cause between brackets hardness variation. يعني the tablet hardness between brackets طبعا, I like to call it scientifically mechanical strength of the tablet, will change if there is weight variation. إذا weight variation cause also hardness variation or mechanical strength variation of tablets. طبعا usually the lower the tablet weight among the group of tablets, the lower the weight, the lower its mechanical strength. يعني when you don't have enough filling here in the die cavity, so the upper punch descends here to do the compression, right? But when there is not so much filling inside, the die cavity will not be able to cause strong compression on the formulation that is in the die cavity. يعني the upper punch will descend, for example, 2 millimeters or 3 millimeters inside the die cavity. If there is no enough formulation inside, then this will not cause good compression. So now we know what are the reasons that might cause weight variation. Now we want to talk about the procedure and how we can say that there is weight variation or there is no weight variation. يعني the batch passed the test or the batch of tablets failed the test. In the process you take 20 tablets, يعني 20 units, and then you will need to weigh each unit individually. So you will have how many weight? You will have a total of 20 weight, right? Okay. Now, after you have the 20 readings, then you calculate the average weight. The average. How do you calculate the average weight? The average weight can be calculated by summing all these weights. يعني you will sum 20 weights. This weight plus this weight plus this weight plus this weight plus this weight, and so on. Then divided by 20 اللي هو the total number of units. You will get the average. So your average will be something in milligram. For example, 100 milligram or 200, 300, 350, 367, etc. 511. Then, according to the British Pharmacopoeia, you need to refer to this table. This table says, look at the average weight. Now, let me assume that the average weight is 600, okay? So I have an average weight of 600 milligram. So look at the table here. Where is 600 milligram in these three categories? It's not 80 milligram or less. It doesn't belong to this category. It's not more than 80 and less than 250. It is 20. It belongs to this category اللي هو 250 milligram and more. يعني 600 comes here. طيب. Look at this number here. Okay, 5%, 10%. Okay, let's come back. It says the percentage deviation of individual tablet. For you to know how to do it, you need to calculate the percentage of weight of each tablet relative to the average. For example, if the first tablet weighs 5, okay, let me write it. If the first tablet weighs 500 milligram, then how do you calculate its percentage from average? You divide it by 600 and then multiply it into 100%. Okay? If the second one is 700, then you divide it by 600 multiplied by 100%. So you need to calculate the percentage of each one of these 20 tablets from the average that you got. Let's see the first one, the first tablet. Okay, so the first one will be 83.3%, right? 0.33. The second one, $116.66% or 67. Okay, so how many percentage will you get when you do for each of these weights? You will get 20 percentages. Okay, طبعا obviously 600 and 500 are very different. 700 and 600 are very different, obviously. But what you need to do is look at the category here. It says it can be the weight of each tablet can be 100% plus minus 5%. أيوة. Can be 100% plus minus 5. So you will have to look at each of these numbers. All of them should be between between 95% and at 105%. So look at each number. Is it between these two levels, two extremes, 95 to 105? If all of them are within this range, then the test or the tablets will pass the test for weight variation. If one or maximum two are not in this range, if one or two of these tablets, the 20 tablets, are not in this range, okay, then compare it with double the range. Should double the range, بدل plus minus 5 بتصير plus minus 10%. It means compare it with 90 to 110%. Okay, from 90% to 110%. Again, if one or two tablets maximum من ال 20 you have 20 percentages. If one or two are not in this range, compare it with double the range, اللي هو 90 to 110. If they are within the double the range, 1 or 2 tablets only, then also it passed the test. يعني it can pass the test if all the tablets are within the first range. If 1 or 2 tablets are not in the first range, these 1 or 2 tablets should be in the second range. Is that clear? Okay, here you have a homework for you to solve. Suppose you go to a batch of tablets and you take randomly 20 tablets and you measure the weight of each one. So let's say the first tablet weighs 132.1 milligram. Second one is 118.1 milligram, and so on. So how many weights do you have? You have 20 weights. Count them, you will see 20 weights. What will you do after that? Calculate the average for these 20. Then what do? Take the average and see where does it belong. طبعا you will see that most of them are within about 130 milligram, about. So it should be here. طيب, then calculate the percentage of each one from the average. يعني for example, if the average is 130, then the first one will be اللي هو percentage. Let me go back. Will be 132.1 divided by average. Assuming it is, I don't know what's the average here, assuming it's 130, then multiply it by 100% to get the percentage of each one. So in this case, it will be 132.1 divided by 130 multiplied to 100%. So the first one, for example, is 101.62. 101.62 percentage. So you will need to do this for all the 20 tablets and then find if all of them are within the first range, اللي هو plus minus 7.5%. يعني all of them are between 92.5% to 107.5%. If one or two fail the test, then compare it with double the range. شو بده يكون double the range? From 85%. يلا احكوا to 215%. Okay, so that's how you answer this question. Then you tell me whether it passed the test or not. Now let's remember something. I told you I want you to differentiate between weight variation test and uniformity of content test. Weight variation test focus on the total weight. Total weight شو هو? It will include the weight of the drug and other excipients. Excipients like what? Like diluent, disintegrant, binder, lubricant, glidant. Okay? So it's not only the drug. So you are weighing the whole tablet. Okay. Remember the uniformity of content test. You analyze individual tablet for the drug content. And you only apply that test in which condition? When the drug content is very low in the tablet or the dose is very low. For example, if you have a drug like digoxin, maybe less than 1 milligram in each tablet, then you need to do that. In case you did the uniformity of content test because it is required for the potent drugs and for drugs in the tablet with very low percentage. Because of that, you do not need to do weight variation test, because if there is no difference or there is no significant difference بالchemical content بالtest uniformity of chemical test between the tablets, there is no difference, then we really don't care a lot about the weight variation test, because now we are sure that the tablets will have similar-ish content of drug. طيب, in case the content of the tablet, like for example paracetamol tablet, it says it's labeled as 500 milligram. In this case, you will do which test? You will do weight variation test. Why? Because the content of the tablet is high. It's probably 90%, or let's say 60% or 70% or 50%, whatever, of the tablet is a drug. So in this case, weight variation test will reflect content variation. يعني if there is a large difference في الweights of the tablet of paracetamol tablets, then also there will be difference في الcontents. ليش? Because most of the tablet is made of drug. But in uniformity of content test, اللي هو previous test, only very small proportion of the tablet content is a drug, and therefore variability is possible في الcontent without weight variation. يعني يمكن ما يكون في عنده weight variation, but there is variation في الcontent of the tablets. You get it? Okay? إذن when you have a lot of drug in the tablet weight variation will reflect also variation in the content. No need for uniformity of content. Weight variation is enough. So this is when we do the weight variation test, and when do we do uniformity of content test. طبعا one of them is a chemical test, the other one, اللي هو weight variation test, is a physical test. Is that clear? The second test we will talk about اللي هو disintegration test. Disintegration, remember that we usually add disintegrants to the tablet formulations. For some tablets, you may not need to add disintegrating agents, such as the chewable tablets. Why you don't need to add disintegrating agent like chewable tablets? Because you chew it في المouth, you break it with chewing it. So we don't care a lot about doing disintegration test. طبعا disintegration test is not frequently done. It's done in certain cases. Mainly when the tablets are intended to produce local action. For example, Cinna tablets, which is used for constipation condition, is supposed to act within the GIT. We are not concerned with its absorption. So in this case, we will do disintegration test. Disintegration test versus dissolution test. Now, if the pharmacopoeia asks you to do dissolution test, then you will not do disintegration test. Yani usually they are not done together. You either do disintegration test or dissolution test. The one that is frequently done is dissolution test. Disintegration test is limited لإيش؟ للproducts that need to produce local action. In this case, I'm not really concerned with how much dissolves, how much of the drug dissolves. بينما في dissolution test, yes, it's important to know how much of the drug dissolves in GIT fluid, because this drug needs to be absorbed. So we apply dissolution test للدrugs that are intended to produce systemic action. طيب, what do you mean by disintegration? اللي هو complete breakup of the tablets. يعني the tablets fragments to small pieces. Does it mean it will dissolve? No. But usually, in order for the drug to dissolve faster, the tablet needs to break first. The tablet needs to break first to increase the surface area and improve the dissolution, make dissolution faster. طيب, when can we say that, okay, this tablet has completely disintegrated? Okay, in order for me to explain it to you, I want you to look at this equipment. You will see that there are two stations. Some equipment only have one station. In this station, you will see a basket. There is an upper plate, وفي هناك lower plate held together by long screws. Okay? Now, also between these two plates, you will see fitted tubes. These tubes are open from the top, but at the bottom there is a mesh. Okay, let me show you this in more detail. Okay, this is the basket. Now, this is the lower part of the tubes. طبعا, this is the upper plate, lower plate held together by screws. Now, in this tube, the lower part of the tube is closed, or let's say partially closed, with a mesh. This mesh, the size of the opening is 2 millimeters. Okay, the size of the opening is 2 millimeters. So each tube is open from the top, and there is a mesh of beneath each tube, and this mesh has openings of 2 millimeters each. Another 2 millimeters. Every open is 2 millimeters. Is that clear? So let's go back here. What you see here is a water bath, because we need to add water here and make sure that the temperature is maintained at 37 degrees inside the water bath. طبعا, this can be plus or minus 2 degrees. طبعا, I am more concerned of the temperature inside the beaker. هذا البيكر. Okay. طيب, inside this beaker there will be about 1000 ml of water, or HCl, 0.1 N HCl, or 0.1 M molarity HCl, or just water, and you will add a tablet in each tube. So there are 6 tubes. You will add 1 tablet, and then you will start the machine. When you start the machine, this goes down, descends and goes up, descends and goes up. طبعا, when it descends, the lower part, the plate containing mesh, should be at least 2.5 centimeters away from the bottom of the beaker. Is on this side of the lower plate. When it goes down, it has to be inside the liquid. Okay, and minimum of 2.5 centimeters above the base of the beaker. When it goes up, this lower part should be at least 1.5 centimeter below the liquid level. يعني at all times the tablet should be inside the medium at all times. Is that clear? طيب, After certain specified time, for example 15 minutes for uncoated tablets, you need to check the condition of the tablets. Did they pass through the mesh? هل every tablet passed through the mesh completely? If the tablet, each tablet passed through each mesh completely, then you have disintegration, complete disintegration. So you will have to check each one of them, okay? Now, in many cases, some fragments of the tablet can pass through the mesh, but these fragments do not pass. Why? Many reasons can be there, but one reason is they stick to the mesh, sticking. They will stick to the mesh, and that's why they are not passing. Otherwise, if they don't stick, they will pass. Type in this case, if these fragments are not large, number one, not large, and number two, they are soft, not firm. Soft, yani, if you touch them with, if you press at it at the fragments between your fingers, you will see that they are soft because they are wetted from inside. مبللين يعني. They are wetted from inside. So when you press at them, you will feel that they are soft, easily compressible between fingers. If they are firm and dry from inside, okay, then this means that the tablet did not pass the mesh. Okay, so after, let's say, 15 minutes, I want you to check the condition of each tablet. If any fragments remain, it should be soft and small. Okay. طيب. Now, in case of capsules, let's say you are putting capsules instead of tablets, sometimes the shell of the capsule will stick. If the shell sticks to the mesh, that does not mean there is a failure for disintegration, because we are not concerned with the shell itself, which is sticky, will be sticky fil medium. So it might stick. We are not concerned with that. So capsule shells are not taken into account when we look at the disintegration of tablets, of capsules. And when we look at the disintegration of tablets, it's important that any fragments remain here is soft and wetted. Is it clear? طيب. Now, so you put 6 tablets. Then you operate for, let's say, 15 minutes for uncoated tablets. You look at the condition, and then you decide whether all tablets have disintegrated or not. The speed or the cycles per minute, yani how many times it goes down and then up, down and up, down and up. How many times per minute? It goes from about 29 to 32 cycles per minute. How many minutes you operated for uncoated tablets? You operated for 15 minutes. Then you check the tablets. So how many tablets are there? There should be 6 tablets, 1 tablet in each tube. Okay? طيب, suppose one tablet or maximum 2 tablets, is an 1 or 2 maximum, have not completely disintegrated. Yani the other 4 or 5 tablets completely disintegrated. Then you need to do the test with additional 12 units. Yani take randomly 12 units and do the same test again. First with 6, then again with another 6. Or if you have 2 stations like here, put 6 here and 6 here. In each tube there will be 1 tablet. Do the same test again and find out whether there is complete disintegration or not. In any way, at least 16 tablets from 18. لأنه first I did 6, and then when 1 or 2 did not pass, did not disintegrate completely, I did another 12. So I have a total of 18. At least 16 from 18 should disintegrate within the specified time. Is that clear? طيب. What happens if all the tablets, first 6 tablets, all of them disintegrate within the specified time? In this case, you do not need to do another 12 units, and that would be sufficient, and then you can assume that the tablets passed the disintegration test. Is it clear? I will show you a video. In this video, it shows you the disintegration test, so you get a better idea of how it is done. Okay, you see here, he's putting 1 tablet in each tube, and let me stop here. You will see here a plastic disc. Okay, let me go back. Okay, you see here plastic discs. This disc can be used only when the pharmacopoeia is specifying its use or when it is necessary. These discs intended to keep the tablets under the medium. Yani, sometimes if you don't add this disc and you want to operate the machine, the tablet remains floating, always floating. It doesn't go inside the liquid, and that is wrong. So in this case, what do? You add these discs. Okay? When do you add them? When specified by the pharmacopoeia, or your product or your tablets always float. And this can happen, for example, in case of capsules. Usually capsules will float. Of course, you see here the temperature. It has to be 37 plus minus 2. Now it's working as you see it. It has to be always under the medium. Now in this basket, it's very strange because you see only 3 tubes. Now you use this basket only when the dosage form that you have is maybe large and it cannot fit well in the 6 tubes station. In this case, you can use the larger one, اللي هو containing 3 tubes, as you see in this station. Okay, we'll stop here and we'll continue to the next test. Next test is the dissolution test. Before we talk about dissolution test, you need to memorize the following. For uncoated tablets, usually it has to disintegrate within 15 minutes, and usually we use water. The other thing you need to memorize, if it is sugar or plain coated tablets, yani there is a coating but it doesn't have function. In this case, it generally has to disintegrate within 60 minutes. You can use water or 0.1 m HCl. In case you are dealing with enteric coated tablets, اللي هي gastro-resistant tablet كمان. Also we say delayed release tablets. is an enteric coated tablets, gastro-resistant tablets, delayed release tablets. In this case, it should not disintegrate or dissolve in acidic medium, but it should dissolve or should disintegrate in basic medium. صح? That's why first you will use 0.1 m HCl acid as a medium. So the tablets will be used in acidic medium. What should happen? Nothing should happen. So you operate the apparatus for 2 hours and no tablets should show any sign of disintegration or even crack. لأنه crack means the drug can be released. When you take the same tablets after 2 hours in acidic medium and you place it in phosphate buffer that has a pH of 6.8, يعني similar to the intestine pH, and you operate for 60 minutes, it should disintegrate within 1 hour. Then you should memorize these 3 conditions. Okay? طبعا the limitation, as I said, it's not guaranteeing disintegration, does not guarantee dissolution. If dissolution test is required, no need to do disintegration test. So let's now talk about dissolution test. Now they found that there can be a correlation between the dissolution, which is an in vitro test. شو يعني in vitro test? In vitro test يعني in glasses. We do it in equipment, using equipment outside the bodies. They found that there is a relationship between how fast the drug dissolves or get released and dissolved in the medium in vitro, and what happens regarding the drug absorption in vivo. يعني we assume that the faster the drug get dissolved from the tablet in the medium, يعني the drug gets released and dissolves in the medium, the faster it does that, the faster it will get absorbed. So if we do it in vitro outside the body and the dissolution is fast, we expect also the absorption will be fast inside the body. Okay? So in vitro in vivo correlation. Correlation يعني ايش? They correlate, يعني they go with each other, يعني they have a relationship with each other. إذا correlation يعني relation. إذا حكينا it's inversely correlated يعني ايش؟ يعني if something increases, the other one decreases. Here it's proportionally correlated. It's proportional. But the faster the dissolution, the faster will be the in vivo absorption. فبنحكي لها in vitro, in vivo correlation. Sometimes they give it the abbreviation IVC. شو يعني IVC? يعني in vitro, in vivo correlation. So this correlation can happen in 2 cases, in the presence of 2 conditions. One, the drug that dissolves remain free. What does it mean? It means there is no chelation. It doesn't complex with other materials. For example, tetracycline can complex with calcium, and this will prevent absorption. So once the drug dissolves, it should not be degraded, it should not be destroyed, it should not complex with other materials, it should be free. And the other condition is that the dissolution is the rate limiting step for absorption, which means that the absorption is fast. The only thing that is limiting absorption is dissolution. Okay? So if all of the drug dissolve at once, also absorption will happen very quickly. If dissolution is slow, absorption will be slow. So the problem is not with the absorption, it is with the dissolution. That's why we say dissolution is the rate limiting step rate limiting step. يعني هو اللي بيحدد الرate for absorption. The faster the dissolution, the faster the absorption. The slower the dissolution, the slower is the absorption. طيب, let's talk about dissolution. There are two main apparatus that can be used to test tablet dissolution. The first apparatus is referred to as apparatus 1 and also referred to as basket apparatus, because you have to memorize these things because you may have them in the exam. طبعا apparatus 1 is the preferred apparatus في British pharmacopoeia. Later you will see apparatus 2 اللي هو pedal apparatus, and apparatus 2 اللي هو pedal apparatus is preferred in the United States pharmacopoeia. Okay, let's look at the assembly. You see here dissolution apparatus with multiple stations. If you count them, 1, 2, 3, 4, and there is another 4 behind them. So this is 8 station dissolution apparatus. Look at it carefully. You will see 8 vessels. This is a vessel. The vessel can accommodate 1 liter of medium, and the bottom of this vessel is hemispherical. Hemispherical يعني شبه دائري. Now all these vessels are in a water bath. This is the water bath, because I need to control the temperature of the medium inside the vessels. إذن في water outside the vessel with controlled temperature, and that is to control the temperature of the media inside the vessels. Is it clear? طيب, you will see here shaft, and the bottom of the shaft is connected with a basket. شوف تطلع هون هذا basket. أيوه, similar to this one. Now each one will have a basket at the bottom. طبعا before we fit the basket into the shaft, we have to add the unit, the tablet. For each one we will add. طبعا we are not using all these. There is only one of them we use. One kind يعني we use depending on the pharmacopoeial specification. Okay? The drug should not interact with the material of the basket. طيب. So at the beginning this is raised, or the shaft is actually outside, and the basket is detached. Put the tablet inside the basket, then fit it in the shaft and fit the shaft in the machine. Okay? Fill the medium inside the vessels. Wait until the temperature is 37 degrees Celsius. Yeah, the temperature of the media inside the vessel should be 37 degrees Celsius. So it is the same or similar خلينا نحكي to the disintegrating apparatus. برضو الميديا has to be 37. But see the difference here, because this difference is very important. With disintegration it's allowed plus minus 2 degrees. Here it's only allowed 0.5 degrees. يعني it can be 36.5 to 37.5. It cannot be more, it cannot be less than 36.5. It's difficult to control the temperature of the disintegration apparatus. If we go back, it's difficult to control the temperature here. Why? Because the basket goes away from the beaker. As you see, it's up now, and it's exposed to the environment. The beaker is exposed directly to the environment, so controlling temperature here is more difficult than in the case of dissolution apparatus. So if we go back, you will see that each vessel will be almost completely closed with a cover to prevent the evaporation of water and at the same time to maintain the temperature inside. طيب. Now this shaft rotates, so you need to set the speed of shaft rotation. Usually it's 100 rounds per minute, but it can be 75 or 50. And the medium that you add here, the volume of the medium is also important, similar to the temperature. ليش the temperature is more important here? Because dissolution is very sensitive to the temperature, right? Because of that, you need really to control it very well. طيب الvolume also you need to control it very well. It has to be within plus minus 1% of the volume specified in the pharmacopoeia. يعني if the pharmacopoeia says 900 ml, it has to be plus minus 1% of the 900 ml. Because you know that the volume will affect also dissolution. The more I add, the faster the tablets will dissolve. Another very important thing is the pH of the specified medium. For example, let's say I said phosphate buffer, use as a medium phosphate buffer with a pH of 6.8. Then it should not be more or less than 6.8 by 0.05. يعني it will be ايش? It can be from 6. يعني the pH can be from 6.75 to 6.85. That's all. طب ليش? Why? Again, the pH or the dissolution, and you studied that in Physical Pharmacy 1, the dissolution can be significantly affected by pH. For example, if you have an acidic drug, it will dissolve faster if you increase the pH. And if you have basic drug, it will dissolve faster if you decrease the pH. It has a relationship with the dissolution. That's why you need to maintain it. Okay. So what is the usual way of operating this machine? What are the specifications? How can we say, okay, the tablets pass the test for dissolution or it doesn't pass? طيب, first, you need, as I told you, to put the tablets in the basket and then set the rotation of the shaft to 100 rounds per minute. And then, according to the pharmacopoeia, you need only to take one sample from the dissolution medium, usually at 45 minutes. Okay, طبعا depending on the pharmacopoeia. You have to go, for example, paracetamol tablets, they will tell you take at 30 minutes. So you need to refer to the pharmacopoeia, but I'm talking about the common way. So set the rotation at 100 rounds per minute. After 45 minutes, take a sample, withdraw a sample from each vessel and analyze how much of the drug has dissolved. بالpoint 45. إذن pharmacopoeia is only asking you to take 1 point. In case you want to take multiple points, in this case, if you take مثلا a sample here, let's say 5 ml or 10 ml sample from each vessel, you need to replace it with the same medium at the same temperature. إذا أخذت 5 ml containing the drug in solution من هون, then you need to take medium that has no drug and put it back, but it has to be إيش at the same temperature. That's why one of the vessels here, I have 8. Usually I will use only 6. What about the other vessels? We usually keep them to إيش to maintain fresh medium. الميديم اللي بستخدمه, الليكويد اللي بستخدمه that I use, the liquid that I use, at the same temperature, to maintain it at the same temperature without any drug, without any tablet. So if I take 5 ml from a vessel, I need to take 5 ml from a fresh medium at the same temperature and replace it. That is only in what case? In the case I need to take multiple points. يعني for example, sample at 5 minutes, sample at 10 minutes, sample at 20 minutes, at 40 minutes, and so on. So each time I take 5 ml, I have to replace it with the same volume of medium at the same temperature. Okay, the other apparatus اللي هو البedal apparatus اللي هو apparatus 2, instead of basket at the bottom of the shaft, there will be a pedal. Pedal يعني زعنفة, يعني زي فراشة, زي مروحة, okay, like a fan, in order to stir the medium. Let me show you here. Here you see hemispherical bottom vessels, and instead of the shaft there is a pedal, بس في replacement. This means that the tablets you put here will not be inside the basket. It will be إيش at the bottom here. Okay, now this is usually or recommended by the United States Pharmacopoeia. يعني when the United States Pharmacopoeia asks you to do dissolution test, usually it asks you to use apparatus 2 اللي هو البedal apparatus. Okay, for myself and from my experience, I prefer to use the basket apparatus اللي هو British Pharmacopoeia. And the reason why I prefer to do that is sometimes if you use capsules or some kind of tablets, they may float. يعني instead of sinking to the bottom here, they float, and this is wrong. Now, to solve this problem using اللي هو pedal apparatus اللي هو apparatus 2, to solve this problem, they said that you can use a sinker. شوفوا. So you put your capsule or your tablet inside these pieces to make it heavy and to keep the capsule or the tablet at the bottom here. Do I need this in apparatus 1? No, I don't. Why? Because the tablet or the capsule is kept inside the basket and the basket inside the medium. So I don't need that in the basket apparatus. I will show you now a video of the sinkers used so you get the idea.
Hello, my name is Mark. Welcome to Lab Hub Training Videos. Today we're going to talk about capsule sinkers. Here we've got the 6 most common types of sinkers used in dissolution. This one is the Japanese basket and is referenced in the USP. This one is called a Sotak style sinker, a 3-pronged sinker, a basket sinker, and 2 types of spiral sinker. This one is stainless steel and this one is PTFE coated wire. The main difference between these two is that the wire sinker is magnetic. The Japanese basket has a lid on the end which simply flicks open, the capsule fits inside and the lid is closed again and the capsule is held inside the sinker like so. This is the Sotak sinker. This one has a spring that pushes backwards and forwards. You can push it with your finger. Simply push the spring back, take the capsule, slips inside and the spring moves back and the capsule is inside the sinker. To use the 3-pronged sinker, simply take your capsule, align it along the capsule sinker, and push the end in with your thumb, and the capsule is aligned with the legs. This is the basket sinker. The basket sinker has a top that lifts off. These are designed for coin-shaped tablets, so you can take a tablet like this, drop it inside, and simply push the lid on. With the spiral sinker, the coil on the end moves to allow access to the sinker. So to put the capsule in, simply take the capsule, push the coil aside, and just simply push the capsule in. The coil flicks back into position and the capsule is held in the sinker.
So in order to avoid using sinkers, I personally prefer apparatus type 1, but it's not up to me. We need to follow the pharmacopoeia when we do dissolution testing. طيب, remember, I told you that you need to draw only one time at 45 minutes. In this case, you do not need to replace the medium you withdrew. And the temperature must be kept 37 plus minus 0.5 degrees. And the pH of the medium must be maintained within plus minus 0.05. Now, let's talk about the process. The process can be multi-stage, يعني different phases, مراحل. If it doesn't pass one stage, first stage, you need to go to the second stage. If it doesn't pass the second stage, then you need to go to the third stage level. شوفوا S1 اللي هو level 1, level 2, level 3, or stage 3, stage 2, stage 1. So in the beginning, you only need to test 6 tablets. So you put in each vessel, you put 1 tablet, and then after the specified time, if it is not mentioned, then إيش حكينا, it has to be 45 minutes. Then at 45 minutes, withdraw a sample from each vessel. Okay? So how many samples did you draw, if that's your experiment? In this case, you will have إيش? You will have the sample in one tube, another sample in another tube, third tube, fourth tube, fifth, 6 tubes. So you'll put your 5 ml or 10 ml that you drew from each vessel, you put it inside the tubes. So now you have 6 tubes containing a sample from the dissolution medium. What do you need to do with each one of them? You need to take them for analysis. يعني analyze each one individually, separately. You can do it, for example, using a spectrophotometer or HPLC. You can look at the pharmacopoeia because it will tell you what analysis you should be doing. يعني حتى the analysis to calculate how much drug is there in each tube is given is given in the pharmacopoeia. So when you do analysis for each one, so you are doing analysis. This analysis will give you how much drug is there. So you know how much drug is in each tube. Let's say here I have certain amount of drug, So I have 6 readings. I have مثلا tablet number 1 has a certain amount of drug. Okay? طيب, from that, let's say there is, in the first one, there is 1 milligram. طيب, 1 milligram was in 5 ml. صح? When you analyze the first one, you got, according to analysis, there is 1 milligram of drug dissolved here. But this is in 5 ml. طيب you know that in the medium you used 900 ml صح؟ يعني if you go to the vessel here, if you go to these vessels, you may be asked to put or to pour in 900 ml or 500 or 7 or 800. So if 1 milligram is in 5 ml, so how much of the drug has dissolved في 900 ملغ؟ طبعا you do the calculation، تكتبوا مثلا 1 in 1 ب 5 قديش how much in 900 and then you can do the calculation. طبعا it will be, let's say, it will be the drug amount will be في النهاية قديش طلع لنا how much 180 milligram. That's how much dissolved in 45 minutes vessel 1. So you do the same with the others. You analyze here and you find out at the end you know how much dissolved in the vessel, each vessel from each tablet you located inside it. Okay? طيب. Suppose the tablet, the product you have, the tablet says or the product says that in each tablet there is 200 milligram of the drug. In this case, what you can do, you can calculate how much of the claimed amount, الادعاء, يعني what the company is saying. The company is saying each tablet has 200 milligram. So in this case, you can tell how much of the 200 milligram had already dissolved. How? Divide 180 by 200, multiply into 100%, and you will get a dish. You'll get 90%, for example. So how many percentage will you get? You will get this is 90, maybe 95, 85, 70, etc. Right? So you will get how many numbers? You get 6 numbers. Now, what is the criteria to pass? It says if each one of the vessels, the drug from the tablets dissolved by not less than Q plus 5. Q plus 5. طيب. Q is given in the pharmacopoeia. If it is not given, then usually it means 75%. Let me show it to you here. If Q is not given, then consider it as 75%. طيب 75% plus 5 is equal to a dish 80%, right? طيب, it means look at each one of the 6. Are they 80% or more? If all the 6 are 80% or more, then خلاص, you stop and you say ايش? Your batch of tablets pass the test. Is that clear? يعني you see how much drug dissolved in each vessel. How? You drew a sample from each vessel and then you analyzed each sample and then you calculated how much drug is there in the 5 ml you drew. بعدين how much there in the whole medium في الvessel. بعدين you divided how much dissolved in each vessel by the claimed. الclaimed شو حكينا? The one that you write in the package. مثلا paracetamol 500 milligram or another drug is 200 milligram. Okay? That's the label, that's the claim. multiply that into 100% and you will get how much dissolved in the vessel from the tablet. طبعا if you leave the tablet longer in the vessels, more will dissolve. Okay. طيب, so if Q plus 5 يعني 80%, بس حكينا Q, you see it in the pharmacopoeia. If it gives you Q مثلا 80, then it means 85. 80 plus 5. If it doesn't give you Q, then Q can be considered to be 75%. طيب, so if each tablet has dissolved by at least 80%, then pass the test. If this is not the case, suppose 1 or 2 or maybe all, they are less than Q plus 5, yani they are less than 80. In this case, you take another 6 tablets and repeat the experiment, do the same thing. So before you did 6 and now you are doing another 6 in stage 2. فبصير عندكم ايش؟ Now you have 12 units. شو يعني؟ 6 from stage 1 and 6 from stage 2. فصار عندكم ايش؟ 12 units. Now for 12 units معناته you have now how many percentages? You have 90, 85, etc. So now you have 12 readings. 12 reading ka percentage. Find the average of these percentages. يعني اجمعوا 90 plus 85% plus مثلا 75% plus 95%, etc. اجمعوا sum all the percentages of the 12 units. 6 from the beginning and 6 from stage 2. So get the average and divide the total of percentages of 12 units by 12. You get the average. Now, if the average is equal, the average of 12 units, percentages, is equal or greater than Q. Q اللي هو ايش؟ 75%. إذا أنا هلا هنا here for each unit هلا صار عندنا 75% لإيش؟ للأفريج. اوكي؟ إذا أنا نقصت هنا I reduced the إيش؟ the dissolution. If the average is at least 75% and في شرط تاني, no unit is less than Q minus 15. طب Q قديش؟ حكينا 75 minus 15 60%. إذا the average is at least 75%. No unit. شو يعني no unit؟ مش I have 12 readings. Each reading must not be less than 60%. اللي هو Q minus 15. طيب suppose طبعا هذا stage 1. هذا stage 2. طيب stage 2 فرضا ما تحققش. For example, let's say one unit is less than 60 or the average is less than 75. فإذا ما تحقق this did not succeed في second stage. Then you need to go to third stage. بس بالthird stage you will need to take 12 more units. مش 6. في first stage 6, second stage 6. Now third stage you need to take ايش؟ 12 more units. طيب بال 12 more units معناته what are the total number of units صار عندكم هلا ماخدين 24 units. 6 from the first stage, 6 from the second stage, and 12 which you are doing in the third stage. طيب شو بيحكوا لكم in order to pass? It says the average, the same here. The average should be ايش؟ at least 75. ايوه. Average of ايش؟ 24 units. يعني you need to calculate the percentage for 24 units. Already you did for 12 units من stage 1 6 and stage 2 6, total 12, and now you perform another 12 units, so you have 24. So calculate the percentages of all of them and then get the average percentage. This average percentage should be at least equal to Q. والQ قديش؟ أيوه 75%. طيب بعدين not more than 2 units are less than Q minus 15. يعني ناخذ هاي هون not more than 2 units are less than 60. طيب and no unit is less than Q minus 25. Q minus 25 يعني 50. إذن لازم تحقق كمان no unit is less than 50 now. إذن average at least, average of the 24 units is at least 75%. Not more than 2 units يكونوا less than 60%. And no unit at all should be less than 50%. If these succeed and you achieve them, or the tablets pass these criteria, then you can say that your batch of tablets passed the dissolution. Okay, I will show you now how the dissolution apparatus work, and please watch with me. Okay, now we will continue to the other test, which is focusing on the mechanical strength of tablets. So you know that tablets will be ejected from the machine. It may also be subjected to coating and then packaging and transportation. All of these things will cause stress to the tablets. So the tablets might break, or it may not withstand all these stresses. So in order to test the mechanical strength of tablets, we have two categories of tests. One is referred to as fracture resistance methods. Okay, and here we are going to talk about resistance to crushing. Now, I want you to know that in many books and commonly it's known as hardness test. Yani resistance to crushing is known as hardness test, but As I told you, it's not scientific to call it hardness. We will call it resistance to crushing. The other category of tests or methods is referred to attrition resistance methods. Attrition resistance methods. And the test that we will talk about is referred to as friability test. Now, why would a tablet be not strong enough? I already explained to you one of the reasons, and one of the reasons اللي هو formulation flow, and you might have a problem of flow because of damp mass or over drying. You remember when I said that there is an end point to the drying and there should be some moisture in the granules, maybe 5%, 4%, or 3%, and that is to aid in the compression. Okay? Now, over dryness will not only decrease the compressibility of the granules, but it will cause the granules to charge. يعني يصير عليها charge, شحنات. Okay? And this will affect the flow when there is over dryness. The other reason, variation in granule or particle size, or we did not add enough glidant, or we did not mix the glidant well. So these are to do with formulation flow. Another reason is that I did not add enough binder or added too much binder. Too much binder will cause the tablet to be harder. Less binder will cause the tablets to be softer or less resistant to crushing. Another obvious reason is the compression force that I apply. If I apply very low compression or soft compression, the tablets can break very easily. For example, if you remember the rapidly disintegrating or dissolving tablets, اللي هي orodispersible tablets, one of the methods كانت اللي هي apply soft direct compression. طيب, what is the disadvantage of doing that? Disadvantage is the tablet can break easily. So, what cause problem with the mechanical strength of tablets? اللي هي not adding the right quantity of the binder, the applied compression force, formulation flow, these can affect tablet strength. Anything that can affect tablet strength can also affect tablet disintegration, dissolution, and of course response to mechanical stresses اللي هي during handling, as I said, ejection of tablets, packaging, transportation, etc. Now let's talk about the first category, low fracture resistance methods, and we will talk about resistance to crushing, commonly known as hardness tests. Look at the apparatus here. This is the apparatus. You will see طبعا this is manual, this is automatic. You will see inside the apparatus that there is a jaw. Actually there will be two jaws, فكين يعني, two jaws. One is stationary and the other one is movable. So the movable part, when you place the tablet, the movable part will start exerting stress or pressure on the tablet until it breaks. The moment it breaks, it registers the force needed to break the tablet, usually in Newton. Okay? How do you carry out the experiment? You take 10 tablets and then you place each tablet in a clean place between the jaws. Remember always, this is important, that the direction of the tablet with regards to any mark, like for example, sometimes the shape. If you see here, it's like caplet shape. So in this photo, what you see here, it's positioned in its longitudinal direction, or in the lengthier part of the tablet rather than the width, the length rather than the width. If there is also a break mark, like in case of Benadryl, so you need to do or you need to position the tablets always in the same position as you started. It doesn't matter the position in the beginning, the first one, but after that you need to use always the same position as the first one. I want you also to know that most machines will also measure, in addition to the breaking strength or resistance to crushing strength, it will also measure the diameter of the tablet at the same time. And at the same time, it will measure the diameter and the resistance to crushing strength. So you need to take 10 tablets, position the tablets always in the same way. Before you position any tablet, first clean this area from any broken parts or fragments of previous tablets. طيب, register the resistance to crushing strength. Register 10 readings because you will be using 10 tablets. So for each tablet you have a reading. And then the pharmacopoeia does not say when it will pass or fail. It doesn't give you information about that. Who knows why? مين بيعرف why it doesn't say what should be exactly the resistance to crushing? Who knows? Think about it. The reason is some tablets are intentionally made stronger so that it takes longer time to dissolve, and some tablets are intentionally made softer so that it can dissolve more quickly. So it depends on the manufacturer and the pressure they use to produce the tablets for the function of the tablet, whether to dissolve very quickly or take longer time during the dissolving process. That's why what you need to do is record the 10 readings, calculate the mean, average يعني, and calculate the maximum reading and the smallest or the lowest reading you get. But how would I know that the resistance to crushing strength that I got are normal for tablets? Well, usually the resistance to crushing strength range from 4 to 20 kilogram force. Okay? And that's the force that is required, or that is the range that is required to crush tablets in general. Of course, if you go from 10 to 20, then you are going to harder tablets, and maybe because you want to have a sustained release tablets. If you go to 4, then maybe you want something that is softer, that can dissolve very quickly. In many cases, tablets or normal tablets have a resistance to crushing measurement of about 10 kilogram. Now, usually, as I said, the machine will give you the reading in Newton. If you want to convert it to kilogram, then you need to divide it by the acceleration due to gravity, which is 9.806650. Okay? I want to show you a video to explain to you or demonstrate to you the working of the resistance to crushing machine.
The Kaliba model THT-15. The DHT15 is an easy-to-use economical tablet hardness tester. It can operate as a constant speed or constant force tester and measure up to 99 samples per run. The test results are displayed via the LEDs. Any combination of thickness, hardness, and diameter can be tested. The tester has the capability of testing in newtons, kilobonds, and strong cops. Various printers can be attached via the standard USB port on the side of the tester. The printout contains actual values as well as statistics. For more information on this and other Caliva products, please contact Burns Auto.
Okay, so I hope you understood the working of the resistance to crushing machine. Usually they call it, as I said, hardness machine or hardness testing machine. The other اللي هو attrition resistance method, we will talk about friability test, mainly focusing on the uncoated tablets. Well, this machine has a drum, as you see it here. This drum will be rotating with tablets, okay, to see whether the tablets will break or will lose weight when they tumble inside the drum. طبعا the tablets, you will add tablets here. Minimum number of tablets to be added is 10. So you add tablets here, and then this rotates. This rack here will take the tablets up and then will drop them down from the center. Again, the rack will go down, will take the tablets again and take them up, and then we'll drop them again from the center. The distance or the height of dropping is about 15 centimeters or 6 inch. This will continue for 100 rounds, and the machine usually operates at 25 rounds per minute. معناته how many minutes do we need to complete the 100 rounds? We need 4 minutes, okay? So how is this test is done? How the test is done? Okay, first you need to make sure that the drum is clean from inside, no dust, nothing, no particles. And then you will take number of tablets. Now the number of tablets, as I said, minimum is 10, but it depends on the weight. You need to take as close as possible to a total of 6.5 grams of tablets. This can be 18 tablets, 15, 30, 25, depending on their weights. So I need a total of, total weight for the tablets equal to as near as possible to 6.5 gram. Okay, so note that weight and put it inside the drum. As you see here in this photo, there are some tablets here. Okay, as I said, the minimum that you can use 10. If 10 tablets weigh 10 grams, it's okay. You understand? So put your tablets inside and then operate the machine, as I said, for 100 rounds. It will be 25 rounds per minute usually, and that is the requirement in the pharmacopoeia. So for 4 minutes you do this, and at the end take the tablets out. If you see visible fragments of the tablet, they broke because of their tumbling inside the drum, then the tablets fail the test. Now, Remember when I was talking about lamination or capping of the tablets? Do you remember this? It's before the quality control. I said one of the problems that you might see اللي هي الcapping والlamination. Remember when I said sometimes when you look at the tablets, you see them visibly that they are okay. There is no capping or lamination. When you do this test, اللي هو الفriability test, if there is some weakness in the tablet that was not visible or was not demonstrated when the tablets were ejected from the tableting machine, then this test, الفriability test, can show you this problem. فإذا في هناك capping lamination that are not visible initially in this test, you may see this problem. Okay? But the tablet will have horizontal cut, either at the top or bottom or in the middle, and this means that maybe there was some problem in the formulation, too much fines, or there is air inside, or the compression was done very fast, etc., etc. Please go back or refer back to the my explanation about capping and lamination في part 1. Okay, is it part 1? I think so, or part 2. Okay, so if there is any visible crack or breaking of the tablets, it fails the test. If the tablets, you could not make a judgment whether some tablets or one tablet have some fragments or something like that, you could not make a judgment, or when you weigh the tablet again after the test, after the 100 rounds, you need to remove the tablets and weigh them again. If you weigh them and you find out that the percent loss is more than 1%, يعني في حالتين, if you cannot make judgment about if there is a fragment lost or not, you could not make this judgment, or the loss is more than 1%, the loss of weight. Why this loss of weight? Because maybe some particles or something they stuck to the drum from the tumbling process. In this case, you need to repeat the same test again, yani do the same exactly again. Now, if the average loss, friability, yani friability means breaking ability of the tablet. If the average loss, if the breakability of the tablet shows you that it is more than 1%, if the average loss is more than 1%, then it fails the test. If there is any clear visible breaking in the tablets, also it fails the test. Okay? But if you repeat it 2 more times and the average of 3 is less than 1% and there is no clear indication of any break in the tablets, then it will pass the test. طبعا when you repeat the test 2 times, you need to get fresh tablets. Don't use the same tablets. You need to get fresh tablets and repeat the experiment. Now, for some cases, a special type of drum is used, but you use them in special cases. For example, when the tablets that you are using, they stuck or they stick to each other. And if you're sticking all the time. So in this case, you will use such drum. In such drum, there are like what you see here, there are flanges or racks making about 10 degrees angle, about 10 degrees. And these are to allow the tablets to fall freely, because it's very important that they fall freely. They don't stick to each other when they are falling. For example, 2 tablets might be always sticking to each other, whether they are going up or falling down. They are always sticking with each other. This is wrong. For me to show you the video to illustrate for you the friability test, please watch the following video. Okay, طبعا all these equipments we have them in our labs, in pharmaceutical technology lab, so it will be a good idea to ask the lab supervisor to show you these equipment. Okay, the last test is uniformity of tablet diameter test. You want to make sure that the tablet diameter is very similar. This test was at one time a pharmacopoeial requirement, but it is no longer there because if there is a problem with the diameter, it could be checked by weight variation and some other methods. But in any way, usually the hardness tester or the resistance to crushing tester, as I told you, can do both, usually does both, and it will register for you the diameter as well as resistance to crushing strength. If there is a difference with diameter, this means what? This means that there is a wear out and tear in the die cavity. Yani die cavities are not the same because of wearing. Yani I'm using them for so many years, and this might cause them to wear and tear and widen. Okay, in this test you take 20 tablets and you measure the diameter or the thickness of the tablet. You can measure it. So for 20 tablets, each tablet register its diameter and then get the average of the 20. معناته how many readings you have? You have 20 readings for the diameter. Then what you do, you calculate the average. Then what do? you calculate the percentage of each tablet diameter from the average. يعني for example, if the average is 12 millimeter, that's the average, then you have to divide each of the reading of the 20 by 12 and multiply by 100% to get the percentage. طيب, now do they pass or fail? Look at the table here which has been taken from the old pharmacopoeia. If the average diameter is less than 12.5 millimeter, it's less than 12.5, then these percentages, all of them should be within plus minus 5%. يعني should be from 95% to 105%. All of them. يعني each one of the 20 percentages should be between 95 to 105, plus minus 5. If the average diameter calculated was 12.5, then the chosen deviation will be 3. يعني all percentages should be from 97% to 103%. All of them. All of them means there is no retesting, there is no additional tests. All of them should be in this range. طبعا we have manual equipment operated manually, and we have the automatic اللي هو resistance to crushing machine. Okay, by this we have finished the quality control tests for tablets. Again, if you have any question, you are free to come to my office, ask me. You are free to email me. You can contact me by WhatsApp in the created group. We can discuss that in the class as well. Thank you so much for watching, and have a nice day.